Hey everyone, welcome back. I am the Electrical Code Coach, and this is the electrical question of the day. Which of the following wiring methods is acceptable for fixed wiring in theaters, audience area of motion picture and television studios, and similar locations? And the correct answer is type AC cable containing an insulated grounding conductor. And of course, what we're talking about here is wiring inside of a theater. And the big takeaway that I want us to have from today is if you'll answer these two questions, you'll be able to find where to go and what to do in the NEC. The first question is, what am I wiring? Physically, what am I wiring? Am I wiring a generator? Am I wiring a piece of equipment? And I wire a luminaire? And where am I wiring? Is this a wet location, damp location, rated location, explosion proof location? Am I in a theater? If you'll answer those two questions, you will always be able to find out where you need to go in the NEC. Today, we're actually going to be heading to Article 520 for the answer to our question. And in 520, we find in 520.5a, acceptable fixed wiring methods in theaters, audience areas of motion picture and television studios, and similar locations include metal raceways, non-metallic raceways encased in at least 2 inches of concrete, and cables such as MI, MC, and Type AC that contain an insulated equipment grounding conductor. What does the term approved mean in the context of the National Electrical Code? And the correct answer is acceptable to the authority having jurisdiction, the AHJ. And of course, that is your inspector. And for the answer to this one, we're going to head to Article 100, and we're going to look at the definition of approved. And that means acceptable to your inspector. But where do they get the authority to even inspect your job, and what code cycle to go by, and how do they have the authority to approve something? And what are their provisions in the code for approving? Well, let's talk about that a little bit, and then I've got 4 very important points about definitions that you definitely want to stick around for. So first off, in your state, there's likely going to be a state code or a state set of rules that brings all of this together. It might just be a blanket acceptance of a version of the NEC, or there might be a code for your state. And I'm going to use Florida as an example. In Florida, we have the Florida Building Code. They passed a law that the Florida Building Code is law, and then they get together and put all of that together. Inside of there, they will also accept other documents. Sometimes they write some of their own codes. Sometimes they take another document and maybe modify it or accept certain parts of it. And then sometimes they will refer to you further in the study, like in the case of the National Electrical Code. Now, there are some Florida-specific codes that they've added in for electrical, but for the most part, they default to the National Electrical Code, and it lets you know what cycle. That's how we get, first off, what cycle we're on. Is going to go through some type of legislative process in your state, and that's how your inspector knows what to judge you by and what you know to work by. Then someone has to grant your inspector the authority to inspect your jobs. It's not just something they can just be like, oh, well, I'm going to start inspecting jobs now. Somebody has to grant them that. Now, you might be in a county and it's granted a little bit different. You might be in a city and there's a building official, and then there may be chains of laws that give the building official permission to have people under them. Every state's a little bit different. Now that your inspector has a code to judge you by, and he's been granted the authority to be the authority having jurisdiction, he is now, or she is now, your inspector. And they have the ability to approve or disapprove your install. But they can't just do what they want, although sometimes it feels that way when we're out in the field. I was an installer long before I was an inspector, and for every 1 ounce of code knowledge I have, I have 3 ounces of field experience. But with that being said, your inspector can't just make things up. They have to do what's called getting there in the code. We got to go from here to there to there. They have to get there in the code. And it starts in your state most likely at the highest level, and then you work your way down to what code book you're in. This highest level said that we're allowed to use this code book to get there to do this, and then you find it in the book. Then at that point, your inspector is granted a certain amount of authority in interpreting that book, and they have their license on the line. But whether they approve or deny you, they better feel confident of where they found it in the code. In the NEC, there are some provisions for the inspector having the authority to approve something based on their opinion, or that they find suitable. Your state or local government may also grant them the power to look at an install a certain way and say, hey, I think it's okay, I think it's adequate, I think it's safe, I think it's okay. But they better feel confident in it enough if they ever got questioned that they're able to get there somehow. That's why you don't find your inspector just saying, it looks safe, don't worry about it, because they're guarding their license. And just like you are guarding your license, you wouldn't just give somebody a blank check who's never installed electrical to go out and work your name. In the same way, the inspector doesn't want to just sign off on your work just because you're a nice person. It goes both ways. You're protecting your license, they're protecting their license. So just keep that all in mind. Somebody has to set out the code, somebody has to grant them the authority, then they, at their risk of their license, can go out and approve or disapprove something. Now let's talk about the 4 places in the code that I want to talk about when it comes to definition. So the first one is going to be 2020 and previous cycles. We're going to talk about code-wide definitions. Then in 2020 and previous cycles, we're going to talk about the .2 definitions. In 2023 and later, we're going to talk about the removal or moving of .2 definitions. And then I want to talk about the 2023 all definitions in one location. Let's go ahead and dive into that now. So the first one, if you are in a 2020 code and previous, when you go to Article 100, those are code-wide definitions, meaning that every definition that's in Article 100 applies generally to all of the sections of the code and all the articles of the code. When you go to the 2020 and previous code cycles, in individual articles, if there is a definition that only pertains to that article, it's going to be in the .2 section. So 250.2 or 680.2, you'll find a laundry list of definitions that only apply to that article. They only work in that article, and you can't take and use that definition in some other part of the code to make your install work. Or as an inspector, they can't use that definition to deny your install based off of that definition if they're using it incorrectly. And the reason definitions are so important is because they change the rules completely. If it's a laundry room by definition, then all the rules of the laundry room apply. If it is a dwelling unit by definition, then all of the code rules for dwelling units. That's why it's so important that you know and understand definitions, because it can completely change your install, not just on the NEC level, but also in all the other codes and perhaps in your local ordinance or state rules. Now let's talk about the 2023. They got rid of the .2 sections. This is 2023 and later. They got rid of the .2 definitions in each article. They're no longer there. They're using the .2 section for another reason. It might be refurbished equipment. I remember it briefly hearing it, but regardless for today, it is 2023 and later. The .2 definition is the .2 section is no longer for definitions. Now in the 2023, all of the definitions are in Article 100. Every single one of them are there in Article 100. And this is a good thing, ultimately, but it put a whole lot of definitions at the front of the book and a whole lot more time looking things up, but it's just the nature of the beast. The biggest thing that I want us to watch out for here is that now not all of the definitions in Article 100 are code-wide, right? Because they're all there. All the previous .2 definitions are now all moved to Article 100. So this is what they've done. If you see a definition that doesn't have an article in parentheses at the end, and I'm getting ready to show you an example, then it is a code-wide definition. But let's pull up a specific definition here. Not really concerned with what the definition says, but I'm really concerned with this last bit right here. This definition of adapter is only true in Article 520. If you see a definition and then you see parentheses around it, it's only true in that specific article. Keep that in mind. If it doesn't have that parentheses in an article listed, then it is a code-wide definition. And in this case, this definition belongs to code making panel 15, which really doesn't matter to us today. I am the electrical code coach, and my bargain is that these videos will add value to you, and you will in turn add value to others. If there's anything you need from me, you can always email me at electricalcodecoach@gmail.com. If you are liking these videos, if you would hit the thumbs up button on this video, it would help. Also, if you want to subscribe and share with friends. So just remember, 2020 and previous, Article 100 definitions are code wide. 2020 and previous, the .2 sections are in the specific articles. 2023 and later, they've removed the .2 definitions, moved them all to Article 100. And if you don't see an article in parentheses, it applies code wide. If you do, it only applies to that code. Can a feeder be protected by a listed ground fault circuit interrupter installed at a readily accessible location instead of individual GFCIs? Those that are specified in 210.8 and 590.6a. And the correct answer is yes, it is permitted. And we're going to dive into the answer to this here in just a moment. But I thought this would be a great time to recap on the 3 different types of conductors that we use in the NEC. The first one is service conductors, feeder conductors, and branch circuit conductors. Let's go ahead and dive into it now. The first type of conductor that we primarily use in the NEC is a service conductor. Service conductors come from the utility and they go to the first point of disconnect on the structure. Usually from that point out on the load side of the first point of disconnect, they are going to be, that's where our service conductors stop, and we're going to move into the second type of conductor. So let's imagine that we had a meter disconnect combo and we brought our service conductors in to the line side of the main breaker. Then we were going to an indoor panel, and those conductors there are going to be feeder conductors. Feeder conductors are conductors on the load side of the service that come from one panel and go to another panel that has overcurrent devices. So if you feed from one panel and that wire feeds to another panel, and inside of that panel you have more breakers or fuses, those conductors there are feeder conductors. And our final type of conductors are branch circuit conductors. They are the final conductors at the last overcurrent device. So if we went from the service riser down to the top of the meter to the top of that main breaker, those are going to be our service conductors. Then from this meter disconnect combo, we fed to an interior panel. Those are going to be our feeder conductors. And then from there, we go out and wire lights and receptacles. Those are going to be our branch circuit conductors. If you'll just search different types of conductors, electrical code coach, I've got a really detailed study on this, but I thought it would be a great time to recap. Now let's imagine electrical's been real good to you and you've built you a nice house, you got your meter disconnect combo and your service riser. And let's imagine that you want to build you a small little garage just off the house, and for sake of argument, this one we're going to say it's only 5 feet away from this meter disconnect combo. And I'll explain why here in just a little bit. You're going to pipe down, pipe over, pipe up, mount you a panel, you're going to establish your grounding electrode system, and now you're ready to wire this structure. You decide that you want to have 5 20-amp branch circuits, one for each individual set of receptacles, because you're going to be running a bunch of heavy-duty equipment, and you decide you're going to run one circuit for the lighting. You do the math up. By the time you buy the breakers and everything else, you decide it's a little bit cheaper to buy one breaker over here that's GFCI protected and run it over the building. Inspector comes out, says it's totally fine. A couple things that you want to watch out for here is that, yes, this may be code compliant, but if any one of these 5 receptacle circuits or the lighting circuit trip, you're going to be left in the dark and the whole building is going to be without power. Now, you may be really sharp in the code and you say, hey, coach, I don't think the receptacle over or this breaker over here at the house meets the definition of readily accessible. That's okay. I respect your opinion. It would depend for me how far away the garage was, because if you look back at the definition of readily accessible, it does say capable of being reached quickly. If this is like 100 feet away from the house, you could definitely argue that that's not capable of being reached quickly. So just keep that in mind as you install this if you decide to use this provision. And just remember that if one of these circuits trip, it's going to leave the entire circuit in the dark. Which of the following statements is true regarding receptacle installations under sinks? The first option was receptacles can be installed in the face-up position under sinks as long as they are GFCI protected. The second option was receptacles shall not be installed in a face-up position in the area below a sink. Receptacles can be installed in any position under sinks if they are in weatherproof enclosures. And receptacles must be installed horizontally in the area below a sink. And the correct answer is receptacles shall not be installed in the face-up position in the area below a sink. And of course, this is what we're talking about here. And for this one, we're going to head to 406.5 G2, and we are going to take a look at this. And this is what we're talking about. Underneath a sink, if you're doing your garbage disposal or if you're doing your dishwasher, you are no longer allowed to, I think it's 2017 and later, you are no longer allowed to install those receptacles in the face-up position underneath a sink, which makes perfect sense. They've expanded the allowances of installing them face up in countertops and work surfaces as long as they are listed for countertops and work surfaces. But when it comes to under the sink, it's one of the areas where it is prohibited. And I have actually done this in the past, believe it or not. Let's imagine that you're at a house and you are doing, and this would have been on 08 code cycle or the 11, but you're at a customer's house and there's an old nasty crawl space and they want to add a dishwasher or disposal. You just go straight in that underneath that cupboard, drill a hole straight down through the cupboard, through the floor, fish your wire down through there, pop up into a 4-square box, and have that 4-square box be mounted just directly to the floor and plug it right in. Now, kind of an old school way of doing it, but I have done it in the past. Of course, since 17 and later, we've not been allowed to do that, so I've not done anything like that since. But, there's lots of ways around this code. And I understand the driver behind this one because, yes, in this case, for one, this GFCI is not in a readily accessible location if it's at the back of the cupboard, in my opinion. But for two, yes, it would trip the GFCI, so it would kill the load side of the GFCI, but you still have hot conductors likely inside of that box, depending on how it was wired. So if you've got water running down in there, yes, you've tripped the GFCI, but you're also creating a bowl for that water to set in, which could potentially leak back up the individual or onto the equipment that it is leaking from. So I understand this code, makes a lot of sense to me. Just wanted to cover it today. I hope you guys are having a great week. If there's anything I can do to help you, you can always just shoot me a text or email me at electricalcodecoach@gmail.com. Let's get to it. When making terminal connections, how should the tightening torque values be determined and achieved? The options were by using a torque wrench set to a standard value, by guessing based off the actual size of the terminal, by using the highest torque value found in the NEC book, or by referring to the torque values indicated on the equipment or instructions. And the correct answer is D. Let's look at the paraphrase code language. It says tightening torque values for terminal connections must be indicated on the equipment or in the manufacturer's installation instructions. An approved means should be used to achieve this indicated torque value. And of course, if you're unfamiliar with what I'm talking about, we're talking about how much do we tighten the electrical connections that we're making up, whether it's in a panel or switches or receptacles. Do we use the 3 squeak method? Do we use the grunt and twist method? Or is there an actual value that we're supposed to be tightening all these connections, and does it really matter? Well, this became a specific code in the 2017 NEC. And it then specifically said, hey, you have to tighten things according to the manufacturer's instructions and specifications. But we could argue that in the 2014 and previous, this code was already into play based off of 110.3b that wants us to install everything according to the listing and labeling instructions. So this has kind of always been code, but 17 and later, it is now a specific code. And we got clarification and more context in the 2020 and 2023. But one thing that I want to get across to us today is that we need to understand the importance of torquing and make sure that we're torquing all of our connections. Now let's talk about a couple of the connections that we need to make sure that we're torquing. Let's imagine that we're installing this electrical panel and it's previous to the 2017 code or the 2017 adoption or later. In a lot of states, a lot of electricians, what we would do is just torque the main connections, all of our big lugs, right? They would all get torqued. That's all the inspectors were requiring. Depending on your jurisdiction, they may have not have been requiring it at all. But did you know that not only are we supposed to be torquing these large connections, but 2017 and later, clearly it states that we have to be torquing even the breakers, the neutral bars, the ground bars, and also all of our switches and receptacles. Anything that has a torque value needs to be torqued, and we need to make sure that we're doing it properly. So where do we find these values at? Let's take a look. You can find them oftentimes on the can, the panel cover, or the back of the panel box itself. So we're talking about the cover or the box that it's in. Remember, the guts are what the panel are, but we call it often the whole assembly, an electrical panel, but the guts are technically the panel. But on the back of that can that is holding the panel guts, or on the cover itself, or on the door, you'll often find a markup just like this. And you just got to take your time and read it. Here it says A and B, and it clearly says main lugs. If you're using the main lug version, you can use 6 through 300 kc mil wire, and you have to torque it up to 375 inch-pounds. Then when we go here, it says AB if you have a main breaker, which in this case we do. We would go, you're allowed to install 3 gauge up to 300 kc mil, and it has to be 250 inch-pounds. Then it says here for our neutral, it will receive in between 6 gauge and 300 kc mil. We have 375 pounds again. And then our ground, it's talking about the main ground here. You can do a 2-aught to a number 4 wire, and it must be 50 pounds. Then when we get here, we get to neutral and equipment ground bars, says here in parentheses, the small holes. You can do 6 through 4 gauge, they must be 35 pounds. You can do 8 gauge, and it must be 25 pounds, or you're allowed to do 14 through 10, and it must be 20 pounds. And if it's not listed on the can or on the device itself, whether it's breaker or whatever, and often the breakers have it right on there, you will find it in the paperwork that came with the panel box or with the box of switches or the box of receptacles. Sometimes you have to go dig to the manufacturer specifications online, and you'll find that a lot of brands are very similar for the same product, like if it's 2 sets of switches or 2 sets of receptacles. But always make sure that you know your torque spec. Now let's talk about how to achieve this. Well, for all of our larger lugs, we're going to use something like this, which is a torque wrench. This is going to be a wrench style. You're going to have your 3/8 or your 1/2 inch or larger, and you're going to snap on your sockets, your Allen sockets, and you're going to torque it down. But did you know that you can also get torque screwdrivers, and they are your best friend as an electrician nowadays? You get in there, you set it to 12, 15, 20, whatever it is, and boom, 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 boom. You can go through, torque them all down, and make sure that you've got a rock solid connection. I am the electrical code coach, and my bargain is that these videos will add value to you, and you will in turn add value to others. Let's go ahead and get to it.